Welcome to the demonstration of the Heliple 2 research project results from Eurostep, utilising contributions from the other project partners of IBM, KTH, Linxwork, Saab Aeronautics and Volvo Cars. Introducing the demonstration scenario, an aircraft manufacturer or prime is collaborating with a supplier sharing the requirements and part design for an air data computer equipment known as an ADC. In addition, there is a field operator of the ADC equipment providing feedback. The tools in the scenario use different approaches to configuration management. The requirements tool is DOORS from IBM. It uses the branching methodology defined in the OSLC specification, where resources are explicitly added to a configuration that's either a mutable stream or a frozen baseline. The Supplier PLM and the collaboration space use ShareAspace. It uses the effectivity methodology defined in the STEPP standards, where resources are filtered based on the date and the object effectivity to determine the configuration. The scenario is working through a simple change process. At the start of the scenario, the prime has many requirements in their requirement management tool DOORS. Similarly, the ADC supplier has more detailed requirements in their PLM tool ShareAspace and also the part structure for the ADC. The prime has shared the top-level requirements for the ADC using OSLC linked data, and the supplier has provided the ADC requirements again using OSLC linked data and traced it to the shared requirement from the prime. The prime has added a part structure for the navigation equipment assembly to the collaboration space, and the ADC supplier has shared an ADC assembly using linked data and added this to the navigation assembly. Finally, the prime has provided the physical structure that is being tested by the operator, and this includes an ADC with serial number 101. This references the ADC part as the design. At the start of the collaboration change process, the operator discovers a problem with the ADC and logs a defect. This defect is shared using linked data and then enriched to reference the physical part ADC 101 and also the top-level requirements from the prime. The supplier reviews the defect and then does an internal change process. A new requirement is added to the existing set, configuration managed using date and object effectivity. A change notice is created and a new version of the ADC. The new version of the assembly and the change notice are shared using linked data. The change notice is then enriched to reference the shared defect and the two versions of the ADC to indicate before and after the change. Finally, the navigation assembly is updated by ending the effectivity of the first version of the ADC and starting it for the new version. The collaborative change cycle using linked data will now be demonstrated. This is the user interface for the collaboration space, showing the types of resources in this demonstration. At the start of the scenario, the prime has many requirements in their requirement management tool DOORS. This is the DOORS user interface. It shows the configuration context in which the user is working and the requirement that will be shared. DOORS has native OSLC support. Next, a quick look at the requirement structure in the PLM tool. Opening the Requirements module shows a list of requirements for the demonstration. A more detailed look is taken of the ADC requirement that is to be shared. Filtering is used to view the configuration of the requirement structure at a point in time and for an object context. Next, a quick look at the part structure in the PLM tool. Opening the Parts module shows a list of parts for the demonstration. A more detailed look is taken of the ADC part that is to be shared. The part includes images and drawing files and a lot of other information. The part structure can be expanded and any child part selected to show the date it was added to the assembly and the details of that part. The demonstration will now show a user in the collaboration space creating a link to a requirement in DOORS. All uses of OSLC and linked resources in ShareAspace were developed as part of this project. In the Requirements module, the requirements list uses different icons to indicate a normal internal resource or the OSLC icon for a linked external resource. The user chooses to make a link to the prime navigation requirement. This opens an OSLC selection dialog where the content is provided by the DOORS requirements tool. First, the user selects a configuration. They are then presented with a list of requirements in that configuration and select one to share as a linked external resource. The new link to the external resource stores only the name and the URL to the resource in DOORS. When the requirement is selected, ShareAspace uses that URL to request an OSLC preview of the requirement, which is then displayed. Below the preview is a hyperlink to open DOORS directly at the requirement. The same approach was used to link to a requirement in the Supplier PLM tool, which is another instance of ShareAspace. This time, a Links Designer adapter was generated to convert the native ShareAspace API into the OSLC preview. The hyperlink below opens the other ShareAspace instance at the requirement. To add the part links, a new OSLC domain was quickly created using Links Designer. This was based on a fragment of the ISO 10303 standards, also known as STEPP. In the collaboration space, the prime has shared a part structure. As with the instance of ShareAspace used as the Supplier PLM tool shown previously, a part can be explored in more detail. The navigation equipment already contains a child that has a link to the part in the Supplier PLM tool. Selecting this part shows the OSLC preview. This was generated by the Links Designer adapter using responses from the native ShareAspace API. Clicking on the link opens it in the PLM tool, which was shown earlier. Finally, the prime has provided the physical structure that is being tested by the operator, and this includes an ADC with serial number 101. This references the ADC part as the design. Opening the Physical Items module shows a list for the demonstration. A more detailed look is taken of the structure of the shared navigation equipment. It has a different structure to the part. Selecting the physical item for the ADC 101 shows the link to the part design on which it's based, and this is the part version linked from the Supplier PLM. The demonstration will now show the collaborative change process. The different tools in this collaborative process have different names for the defects. In Jira, they are known as bugs, and in ShareAspace, they are problem reports. At the start of the collaboration change process, the operator discovers a problem with the ADC and logs a defect. This is the Jira environment used by the operator. It shows creating a very simple bug with a summary and a description. And once the bug is created, reviewing the bug. The Jira bug will now be shared as an OSLC defect in ShareAspace, creating a problem report that is a linked external resource. The user chooses to make a link to the operator's Jira bug. This opens an OSLC selection dialog where Links Designer adapter for Jira has been generated to convert the native Jira API response into an OSLC selection dialog. Because OSLC change management domain does not use configuration management, the user only needs to select the bug. As before, the new link to the external resource stores only the name and the URL. And when the problem report is selected, ShareAspace uses the URL to request an OSLC preview from Links Designer adapter for Jira, which converts the native Jira API response into the OSLC preview. Below the preview is a hyperlink to open the Jira bug. Back in the collaboration space, the problem report is edited to enrich it with more data that's not available in Jira. First, the physical item ADC 101 is added as a problem item, and then the linked navigation requirement from DOORS is added as a second problem item. The preview shows the representation of the information in Jira, but looking at it in the details view shows the additional information that is stored in the collaboration space, which is the two problem items that have just been added. The supplier has added a new requirement to the existing structure in their PLM tool. They decided not to create a new version and instead controlling the configuration using date and object effectivity. They did this by stating the new requirement was only applicable to the new variant of the ADC when it was included in the requirement structure. The information filter was shown earlier to display this requirement structure. Changing the object effectivity shows the structure for that variant. The view of the child relationship shows the start date it became effective and the variant for which it is applicable. This time, instead of using object effectivity, the new version of the ADC part assembly has been created with different children. The details view of the first version of the ADC shows it has a subpart of HC05 Bluetooth module. Looking at the version history, it can be seen there is a new version of this part. Opening this in the details view shows it has a subpart of HS01 high-speed Bluetooth module, and that this was added on the 7th of July 2024. Details of this subpart can also be seen in this view. The new version of the ADC part assembly is shared using linked data. Because the Supplier PLM tool uses an implicit configuration management approach, the resource versions can be selected individually. The user chooses to make a link to the Supplier ADC part version. This is using the new OSLC domain developed in this project. It opens an OSLC selection dialog for the configurations where the Links Designer adapter for ShareAspace has been generated to convert the response from the native ShareAspace API for object effectivity into the OSLC configuration selection dialog. The user selects the object effectivity and are then presented with a list of part versions that are filtered for that effectivity. They select one to share as the linked external resource. As before, the new link to the external resource stores only the name and the URL, and when the part is selected, ShareAspace uses the URL to request an OSLC preview from the Links Designer adapter for the Supplier PLM. This converts the native API response into the OSLC preview. Next in the scenario, the supplier has prepared a change notice in their PLM tool. Briefly looking at the details of this shows that it references the first version of the ADC part as the problem item and the new version of the resulting item. Selecting the parts displays their details. The change notice is then shared using linked data. The user selects the New Link button, which opens an OSLC selection dialog. The Links Designer adapter for the PLM tool has converted the native ShareAspace API response into the format expected for the OSLC selection dialog. As with the defects, because OSLC change management does not use configuration management, the user only needs to select the change notice. The new link is created, and like before, when it is selected, ShareAspace uses the URL to request an OSLC preview from the Links Designer adapter for the PLM tool. This converts the native ShareAspace API response into the OSLC preview. Below the preview is the hyperlink to open the PLM tool directly at the change notice. As shown earlier with the linked defect, in the collaboration space, the change notice can be enriched to reference the shared defect and the two shared versions of the ADC to indicate the before and after the change. The change notice is enriched from the edit view. First, the linked defect is added as the context. And then the first linked ADC version is added as the problem item. And finally, the upgraded version is added as a resulting item. When the change notice is opened in the detail view, each of the references to the other external resources can be seen, and when selected, show their OSLC preview. The final enrichment of the change notice is to add the navigation assembly that was shared by the prime as an item that is impacted by the change. This assembly can now also be seen in the change notice structure. The final step in the collaborative change cycle is to update the navigation assembly to replace the ADC with the upgraded version. This uses data defectivity to maintain the configuration over time. From the change notice, the impacted assembly can be opened in the details view. The assembly structure shows the first version of the ADC. The edit assembly view shows each of the child relationships and the date they were added to the assembly. The original version of the ADC is removed. This sets the effectivity end date on the child relationship. The new version is then added. The start date for the relationship can be entered, or if it is left blank, the current time will be used. The list of child parts now shows both versions of the ADC. When the information filter is off, the assembly structure shows the current assembly, and this contains the upgraded ADC. The filter can be used to see the assembly at an explicit time. When the mode is changed from live to explicit, the exact date and time can be specified. The view is then updated to show the assembly at that time, which for this example has the original ADC. The child parts can be changed asynchronously, and this effectivity methodology will maintain the configuration continuously over time. That concludes the demonstration. The project launched the Federated PLM Interest Group on LinkedIn and hosted a series of webinars. This QR code opens the webinar that explains more about how the differing configuration management approaches of OSLC and STEPP can play nicely. Thank you for watching.